Hello, my name is Alexus.
I'm Michaela, but please call me Michi. Welcome back to our series, Alexus Explain. It's a series in which I ask Alexus questions about science.
And I do my best to answer them. In today's video, Michi is going to be asking me questions about
Rainbows.
rainbows. Like, why are rainbows bows?
Why do they have different colors? How are rainbows made?
Do we all see the same rainbows? Stay tuned to find out. All right.
Okay, 73.
73,000. My eyes are here.
Wait, you have something in your ear.
I'll be back.
Maybe it has to be like that.
Oh yeah, I can do it.
Actually, that's more closer to me. Turn it off. Maybe I'm just
But you could just say Hawaii because we're German. Gross. My toes are so sweaty. So, as you know, we both came to Hawaii for grad school, and since we've been in Hawaii, we've seen a ton of rainbows. A lot.
We have.
Surfing, hiking, driving. We wake up to rainbows around campus.
There are tons of rainbows because campus is in Manoa Valley, which is a pretty rainy place.
Rains a ton.
I like it. Our camera rolls are full of rainbow pictures.
Perfect.
Yeah, so every single time I see a rainbow, I always wonder, why are rainbows bows?
That's our first question.
Yes.
I don't know.
Why is a rainbow a bow?
Yeah, so we think of rainbows as in a bow or an arch shape, but rainbows are actually circles. Did you know that?
Rain circles?
Well, no, that doesn't sound as cool. So rainbows, but they're circles. And we see them as bows or arches because we're only seeing half of the rainbow
Where's the other half?
below the horizon. So the only time you could see a full rainbow, I think, is sometimes if you're like really high up in the mountains, but definitely when you're flying.
Yeah,
That's
I've
when
seen
you
that before.
In the mountains or flying?
Maybe on a picture. Okay, imagine you have a ball that is Earth. Where's the rainbow? Where's the rain circle?
So, okay, even better. It's not anywhere. Like, it doesn't exist anywhere. It doesn't have a location. It's not at a certain point in the sky. Rainbows are just optical illusions that our eyes are creating when the sun's in the right position.
Our eyes make the rainbow.
Yeah, I think it's not physically there.
It's not physically there.
Yeah, it's not fixed. But maybe that's why, you know, when you're like driving and stuff, or when you're moving, rainbows change so fast. But
They kind of travel with you?
yeah, if you're in a car passing by, you always see the rainbow, but it looks different. Right?
I don't really know.
So if we're looking at the same rainbow, your rainbow is going to look different than the rainbow I'm seeing.
We have different rainbows.
Yeah, we see different rainbows depending on where the sun's coming behind you. And
What if the sun is in front of me? Do I not
No.
see a rainbow?
yeah, you never see a rainbow if the sun's in front of you. So the rain has to be in front of you. And it has to be behind you and pretty low. It has to be at the perfect angle to see the rainbow.
That's why, no. Is that why you see more rainbows in the morning?
Yeah, because it's lower. Yeah, it's less likely to see it in the middle of the day.
What if I'm in a building? Does that matter?
Like if we're in here, seeing a rainbow outside.
Yeah, because we're pretty high.
Yeah, it's raining there. The sun's rising in the east on this side of us, behind us.
Yeah. You have
At
the perfect rainbow
Right
watching
angle.
spot.
Because we're so high up. Yeah, there's a big chance of us seeing the rainbow. Or like it being at the right angle.
Does the height of the building matter that much?
I mean, it must. Because, okay, if you're just a person sitting on the ground, I think
You wouldn't see it?
your shadow has to be higher than you to be at the right angle to see a rainbow.
So right now, is it taller than me?
Your shadow?
Yeah. No, it's a little bit lower.
Yeah.
Because the light is pretty high.
Mm-hmm.
Okay. If a wall is right behind you, that shadow has to be higher than you?
No, I think the shadow of you on the ground.
Uh-huh.
The sun's coming from behind you, but kind of low. So your shadow on the ground needs to be taller than you.
But, you know, it's on the floor. I'm taller than floor height. Do you mean longer than I am tall?
Yeah. You know, you see the nice, pretty rainbow, the center of the rainbow, the bottom, you have the rainbow.
Yeah.
The bottom point here.
What's the bottom point?
Okay, like you have the full rainbow, and now imagine it's a circle.
Yeah.
So the part that you're seeing that looks
I
like the
see.
most middle point is where the sun is behind you. Like that middle
That's why
point
it's
is
a
where the sun
circle.
is behind you.
Okay, so how does a rainbow form?
The rainbow forms by you need sunlight and you need water, like raindrops. So that's why we see a lot in Hawaii, because we have plenty of sunlight and plenty of rain. Assume the sun is at the right angle behind you. You have like rain droplets, right? White light, any light we see, like the sun or like a light bulb, like this one, traveling through air at a constant speed.
Traveling?
Just light, like through air. Made up of different colors, is hitting the rainbow or hitting the raindrop, not rainbow. But when it leaves the raindrop, that's when it's forming the nice pretty colors that we see that make up rainbows.
Yeah, like in science class you always have the prism thing.
The prism thing, yeah, exactly. You see that white light
goes
like
in
this, and you get the
come
colors out. Fun fact, you're always gonna see violet at the bottom of a rainbow.
Why?
Because, is that right?
Well, I don't know.
Let me look it up real quick.
Alexis usually knows everything.
Violet's always gonna be on the bottom of a rainbow.
Is it not purple?
Art? I think it's technically violet.
Violet? Sounds like a fancy word for purple.
And red is always going to be on the top, and the order between them is going to stay the same.
Yeah.
And this is because they have different wavelengths. They're all entering at the same point, and based on their wavelength, they get split
But what
and
does
hit
the
at different
wavelength
points.
do?
Why does wavelength matter? Let me look it up.
We got this one, guys.
Yeah, real quick. So why is purple at the bottom of a rainbow?
I love that you can just put whole questions into Google, and you can see that a lot of people ask the same question. Maybe people on Reddit know.
Is this the last one?
I saved it for you.
Thank you. I only have one.
Different wavelengths refract at different angles. That's why they...
Yes.
Why does the wavelength make the refraction angle different?
Why does it? Maybe it's just the way they're interacting with the glass.
Wait, can I read this again? It took us kind of a long time to figure this out.
Yeah, we did tons of math, calculations, whipping out our papers and whiteboard.
Yeah, don't show the whiteboard.
Heated debates.
Okay, so I wanted to know, why does light, when it hits a water droplet, separate into different colors? It's white light going in. Why is there colors coming out?
Yeah, so again, all of those colors are already in the white light that we see coming from the sun. And then it interacts with the water droplet, gets separated into like red, blue, violet, all of the different colors of the rainbow.
Yeah, why?
And the question, why? Air and water, different media, have different refractive indices.
What's a refractive index?
Good question. So a refractive index kind of describes how much it takes to like get through the other side. Does
How
that
hard it
explain?
is?
Yeah, how hard it is to get through this substance.
Okay, so it's harder to get through water?
Yeah, it's harder to
Lead.
get through water than it is air. So once light traveling through air as white light interacts with water, everything slows down a little bit because it has much more things to interact with. Then each color has different refractive indices. So that's also why they refract at different angles.
So when light goes in, it's going to refract at a different angle because of the different refractive index of water, because of how hard it is to get through water.
Exactly.
But then each of the colors also have different refractive indices, so
Right.
they have a harder time in general.
Yeah.
So it's like classroom, a whole class of kids going like into math class. Math class is harder than English class.
Well,
They're all like at the speed learning English, but then math class is harder, so they're going to be at
They
an
just
angle anyway.
slow down.
But then there's Alexis, there's Mishi. Let's say there's my sister too. We all are like differently good at math. So even though we're all kind of slowing down, all going at an angle, we're also separating. Like some of us, like Alexis, get an A minus, but some of us do even worse. So we get a B or C. Okay, so that's why we end up with different colors.
Yes.
As it goes through a raindrop.
Yes. Maybe this just brings up another question, which maybe isn't helpful. We have raindrops and light, which are creating rainbows. So why do we see one rainbow and not a ton of little rainbows in each drop, right? And it's because all of the little drops that we see are creating rainbows. They each have all of the colors going in, all of the colors like going out.
They each have white light going in.
Yeah, but let's say this water drop here is only creating the violet ultraviolet, because it's at the right angle. It has to be like a perfect 40 or something degree angle. That's
for
why
violet light.
Yeah, for violet. Actually, it's red. Maybe red, something like 40. But the angle needs to be exactly that in order to form a rainbow. So like this water droplet.
In order to see a rainbow?
In order to see a rainbow. This water droplet is making up part of the red. This water droplet's making up part of the green. This other water droplet's making up part of the... You know, you're not seeing the full rainbow from each water droplet. You're seeing like some of the red from that one, some of the green from this one.
Okay.
So they're all making up that one rainbow.
Okay, question. How big is a raindrop?
Like on average?
Are they not all the same size?
They're not all the same size. No,
they're not.
Yeah, you've seen raindrops when it's raining light versus when it's raining hard. No, on average they're 2 millimeters, but they can be smaller and I think up to 6.
6 millimeters? Yeah, that's big. That's probably those that came into my eyes when I was smoke fighting the other day. Rainbows sometimes look brighter with smaller raindrops. Maybe because it's just more.
Yeah, I see what you're saying. Like in the mist or something.
Maybe it's like pixels.
Yeah, way more raindrops making up the rainbow. Huh, that's kind of cool.
Hey, you know which question we never answered really? Why is a rainbow a bow? Or a circle? Why is it not a rain line?
Why is it not just a...
Or just a chunk?
Oh, I see what you're asking. Why don't you just see it as a line?
Does it have to do with the angle I look at it? Like maybe the higher raindrop, I look at them from this angle, so that's why they make this color. And then a little bit lower raindrops, I look at them from a different angle.
Rainbows are circular because raindrops are spherical.
Oh!
Is it because your eyes are round?
Doesn't really make sense to me. I just read, we see things in the sky as two-dimensional because we don't have any other visual cues that give us a feeling of having it be three-dimensional.
Yeah, because it's just... Yeah.
You know, like here things have shadows and like look smaller when they're further away. We don't have that in the sky. That's why rainbows and also the moon look flat to us. Crazy.
Yeah, just unless there's a shadow, then you can tell that like, oh, the moon doesn't really look flat.
Yeah,
sometimes
you
could sometimes you could see that it's more like curved.
Can you?
Yeah.
Where do you see moon shadow?
Maybe pictures.
Yeah, I think so. Okay. It's not a rain wall that we're looking at.
Right, yeah.
All the drops glinting the rainbow are on the surface of a cone with its pointed UI. They can be near and far. Other drops not on the cone also get sunlight, but those don't reach our eyes.
That makes sense because it's just from like your field of vision, right? Like you're gonna have all the 42s,
right?
Or the 40 to 42, depending on the angle. And when you're connecting, because it's 3D, you're connecting all of these. Maybe that's why when you see a rainbow and it's just like that little sliver of it. Why is that?
I think it's because there's no rain where you don't see it.
Possible. But why wouldn't you just see a little rainbow? Oh, because that's not where the anti-solar point is. The middle of the rainbow.
Like, this is a really good picture. I like it.
Yeah, maybe we should use it.
Look at it.
So good. Well,
thanks to Steve Beeson from Arizona State University.
Hey.
So, let's say this droplet gets hit
here
from the sun. Some color comes out, and if it hits me at 42 degrees, I see it as red.
Here.
If it hits me at 41.5 degrees, I see it in a different color.
Yeah.
The ones that I don't see between 40 and 42 degrees don't make any color. Is that true?
Right. It wouldn't be at the right angle, so you wouldn't see it at all, I think.
From your field of vision?
From your field of vision.
The 40 to 42 degree angles are a circle.
Anything below 40 degrees is like the inside of the circle that you don't see, and everything above 42 is outside of the circle. You also... Does that make sense? That's why a rainbow looks like a bow.
Other questions? Where do we see the most rainbows?
Can you guess?
Which country?
U.S.
Is it Hawaii?
Yeah, it's like the rainbow capital. I mean, I saw some stuff about Japan, but I think Hawaii is still the best where you can see it. Specifically, Kauai. Do you see rainbows in Europe? In Germany.
What's a rainbow?
That answers that question.
Were you actually asking?
Yeah, in Germany.
Yeah.
A lot.
We have a lot of rain.
Yeah, but not the most sun.
Okay, in the summer.
Okay. I was just wondering if there was a noticeable difference. Like, no, we don't see that many compared to here.
I mean, obviously. Are we Japan?
Are there rainbows on other planets? If yes, are their colors the same? That is a great question.
Does anyone know?
On another planet, it would depend on what droplets in the air are made of and the type of sun it's orbiting. Another liquid would have a different refractive index, so the angle of the rainbow, how big it looks in the sky, would be different. The type of sun would affect the spectra, the bands of the colors in the rainbow. A red sun would make the red part of the rainbow brighter, although all of the spectrum would probably still be there. Imagine you would not observe any new colors that are not present in the Earth's rainbow due to not being able to see outside of the visible spectrum. Infrared and ultraviolet light is present in rainbows on Earth too, you just can't see it. The order of the colors would not change. Crazy though, right?
I'm a little disappointed by the answer. Also, it makes sense.
Yeah.
Should we do a wrap up? What did we learn today?
All right. We have rainbows in Hawaii. Why?
Why? Because there's a lot of rain, there's a lot of sunlight.
Yes. And you need rain and sunlight to have a rainbow.
The sun needs to be behind you.
Yes. In
For
order
you to see the rainbow.
The rain has to be in front of you here.
Uh-huh.
And the sun's going to be like right here. At the right angle to where it's actually a little bit lower than you.
Yes. Sunlight is white light. That just means that all colors,
all of the visible colors, all of the rainbow colors are in white light.
because air isn't hard to go through for them.
Right. So it has a refraction index, which we introduced earlier, of
1?
1. Yeah.
Hey.
You have your air, all of your hair. You have your water droplet.
As soon as the white light hits it,
It's going to slow down. Light's going to move slower in the water because there's just more stuff to go through and interact with. Then the individual colors.
also have a differently hard time to go through water or a different medium. That's why they also refract at different angles. Yeah, violet goes at this angle and then red at this angle.
That's why we always see violet towards the bottom of a rainbow, and it's never going to change. Red we see at the top.
And then we talked about why doesn't every raindrop make its own little rainbow?
Yeah, why don't you just have a ton of little rainbows everywhere? Yeah,
That
the
is
rainbow
crazy.
that you're seeing in front of you.
Is just because you're looking at it from a certain angle. You're going to be looking at this raindrop from this angle, this raindrop from this angle, this raindrop from this angle.
So then you'll be picking up those different refraction angles. We don't all see the same rainbows because we're all like positioned differently. My rainbow's gonna be here. The sun will be here. If you're offset a little bit, your rainbow's gonna look
The
different.
sun is still
like,
there,
the sun will
but-
still be here, but our positions are different.
I feel smarter now. Let's see if we can spot some rainbows and observe what we learned.
It's been kind of rainy here, so maybe we'll have some luck.
It's really faint. So there's a tiny, tiny, tiny rainbow.
Teeny tiny.
Why is it only tiny? Not enough rain.
Not enough sun. One of the two. We'll see another one hopefully.
Oh, it's bright. Oh my god. I think it's only under the cloud because it's only raining under the cloud.
Yeah, that would make sense.
Where's the sun? Okay, let's see where the anti-solar point would be. Probably there. So the sun has to be.
West.
Is that west?
Yeah, it's sunset.
You can see red is at the top, violet's at the bottom.
Just filming the rainbow. It's so pretty. You're so pretty.
I'm so close to the camera.
Yeah. Oh, it looks good. Actually, it looks better now. Do you think you could do it again?
Okay, so you know what? No one ever sees the backside of this rainbow.
You should have been a physicist.
I should have. Do you think it's too late to change my major? Okay, my sister saw our video and she said no one's gonna believe us that we're PhD students. Just not the smartest of all PhD students. No, it's smart to ask good questions.
Yeah, it's good to be confused. It's better than just being like, yeah, sounds good to me. That was so cute. Back to business.
Back to business. I said back 20. Probably no.
Back to business. I think this video is getting really long.
A lot of it is just trash.
Why say more word? Keyword, you trick. It threw me off this.
Okay.
There's a whole episode. Yeah, poor Kevin, seriously. Oh, you're cute.
You're cute. Okay.
I saw that in the video.
What?
Did you see it too?
No.
I'll show you what I meant. You know the Sam and Monica couple?
Yeah.
It was this. That was exactly what you did. That was cute. You're cute.
They always do that.
I know.
That's not how mango. Tastes delicious. Doesn't make you look funny at all.